Hey, I'm Rachel from Noaa Ocean Exploration. So if you've ever watched one of our live stream dives, you've heard us say a million times how vast and unexplored our ocean is, but also how important. With a mission to explore, Noaa Ocean Exploration works with partners, many partners, to explore previously unknown areas of our deep ocean, making discoveries of scientific, economic, and cultural value, and supporting technologies and innovations in technologies and tools. We do this in many different ways, which many of you are familiar with, one of which is through expeditions aboard NOAA ship Okeanos Explorer. During these expeditions, we map the seafloor, we conduct dives using remotely operated vehicles, and test new technologies. Since May, mission personnel and crew have been out on an expedition with multiple parts, taking them from the eastern coast of the US all the way to the Azores in the middle of the Atlantic. Right now, the ship is in port in Horta, Fayal, and the science team that has been at sea during the first 10 dives of the expedition is passing the baton on to a new on-ship science team. Today, you'll hear from Scott France, who was our biology lead these past few weeks and whose voice you've been hearing if you've been listening to the live stream. We'll also hear from Casey Cantwell, our expedition manager for this whole endeavor, as well as Deb Glickson and Shauna Xavier, our science leads for the next part of the expedition. They just arrived on board the ship today, and that's where you'll join them soon. So join me as we head aboard the ship and meet our science party. First, we'll hear from Casey, who's going to give us a little bit of an overview about what it means to lead an expedition and some of what folks have seen so far. Hey, Casey.
Hi, Rachel. Welcome to the Okeanos Explorer. So I think you wanted us to start today with a little bit about ourselves and then kind of run into the expedition, if that works for you.
Sounds great. Yeah, let's hear a little bit about you and
Perfect.
about the expedition.
Sure. So, hi, I am Casey Cantwell. I am the operations chief for Noaa Ocean Exploration. And during this expedition, I'm serving as the expedition coordinator. So what that means is basically that I oversee a lot of the planning and the logistics coordination for our expedition. For this one in particular, for Voyage to the Ridge, this started about 4 years ago when we were first planning to do these expeditions out here at the Mid-Atlantic Ridge. And through a variety of reasons over the last couple of years, including COVID-19, we've had to sort of restructure, revamp, delay for a series of years. But we are finally here, and we are in the third leg of our Voyage to the Ridge expedition. And this year, I'm out here being the EC for this cruise, and it's going to be great. So for me, I got into Noaa Ocean Exploration about 10 years ago. I had just recently graduated from grad school where I studied shallow reef coral ecology, and I had no real idea about the deep sea, but I very quickly fell in love with it through the time that I've worked for Noaa Ocean Exploration. So I would say forever since before that, though, I was always in love with the ocean since I was a little kid. Anything that I could do, I was happy to do as long as it involved some level of ocean. I like to say that I like my nature from the shoreline out and that I don't like any nature from the shoreline in. So there's always been a love of the ocean for me. And I'm sure you're going to hear something pretty similar from Deb and Joanna and Scott when you get a chance to talk to them too. So our expedition, though, here on the Voyage to the Ridge has been focusing on a lot of the different areas that are kind of unique in the Mid-Atlantic Ridge area. So if you imagine the sort of our planet, one of the largest mountain ranges throughout the entire planet is actually based here on the Mid-Atlantic Ridge. It runs pretty much up and down the entire Atlantic continent. And we have we have this giant mountain range that runs up and down from the north all the way down to the south, and it's actually a spreading center. And so it's a really unique environment here where you have, and you'll hear, here you go, see it in a second. You can see the Mid-Atlantic Ridge, and that yellow box there that's highlighting it is the Azores Plateau area. So we've been focusing on that area and then some of the deep fracture zones that are in this vicinity. With this, we've been looking at some of the geology. We've been collecting new mapping data and geologic samples to help support increasing our understanding of the deep sea in those areas and what the geological history is of it. And you'll hear a little bit more about that from Deb in a little bit. And then from Scott and Joanna, you'll hear a little bit more about the biology and how the exciting things that we've been doing to collect some samples on both our recent expedition, which you can see all those dots there, highlight where we collected ROV dives, and where we're hoping to go here shortly. Hoping to basically close some gaps in our understanding of where some of these deep sea ecosystems exist, and maybe close some gaps in our knowledge about understanding how both sides of the Atlantic Basin are connected.
Awesome. Thanks for the overview, Casey. So let's move on with our introductions. We're going to start with Scott France of the University of Louisiana at Lafayette. He was our biology lead for the first ROV expedition, Voyage to the Ridge expedition. Scott is also our office's science advisor for our recent campaign to explore the North Atlantic Ocean. So welcome, Scott.
Thanks, Rachel. I've been asked to tell a little bit about my background, and a story that I like to tell everybody is that I went to college first as a fine arts major. I wanted to be a filmmaker. And I say this so students understand that as you explore your college work, you can change your path based on what you see. I took an elective course in oceanography. I learned about hydrothermal vents, and I just was so amazed that these habitats and these communities could be on this planet. And I wanted to study them, learn more, and see them with my own eyes. So I went to graduate school. I did research on hydrothermal vent amphipods, and I was really fortunate to have a graduate advisor who got me an Alvin dive in my first year. So I was able to see that hydrothermal vent. Just amazing. 25 years later, here I am. I began my involvement with the exploration, the Okeanos Explorer, in 2013. And when I'm not involved in that exploration, I'm a professor of biology at the University of Louisiana Lafayette, where I teach invertebrate zoology and marine ecology. My spare time, I love nature photography, bird watching. People on the ship know that for sure, because if I wasn't in that control room, I was out on the deck looking for birds, puzzles, and hockey. You've already heard about my role in the expedition. I was the biology science lead. And today I'm joining you from the campus of the University of Louisiana at Lafayette. Thanks, Rachel.
Thanks, Scott. I'm glad you got home safe. He just left the ship and had a very long transit.
A long journey.
It's a lot of little flights and lots of delays. And so next we'll hear from our two science leads who are just kind of trading batons, swapping batons with Scott and Ashton, who is our geology science lead for the first leg. We have Deb Glickson from National Academies of Sciences, Engineering, and Medicine. She's our geology lead for this leg. Thank you, Deb, and welcome.
Hi, thanks so much, Rachel. So I'm Deb Glickson. I'm at the National Academies of Sciences, Engineering, and Medicine. And my background is that I really liked rocks and earth science, but when I was a kid, I didn't know what I wanted to do at all. So when I went to college, I sort of randomly took a geology course my first semester of college. And the first thing that my geology professor showed us was video of hydrothermal vent tube worms. I had never seen anything like this before. And it was the most amazing thing that you could start, a kid in college on. So there are these things that look like, lipstick tubes on the seafloor. And he told us all about hydrothermal vents and how he studied the rocks that these biota live on. And I said, okay, that's it. That's what I'll do with my life. And so I have an undergraduate degree in geology. I have a master's in marine geology. And then when I went for my PhD, I studied hydrothermal vent geology, and I studied how hydrothermal vents get created on the seafloor and how they evolve over time. I went out to sea a lot when I was doing my PhD and visited all sorts of exciting places. The best places that my favorite vent sites, I guess I should say, are the one to Fuca, which is off the coast of Washington. That's my first Alvin dive right there. And the Lost City vent fields. So actually my first Alvin dive was at the Lost City vent fields that we'll be visiting on this expedition. After that, after my PhD, I took a marine policy fellowship in Washington, D.C., and that led to my current career, which is science policy. And it's a field that takes scientific information and helps make it useful for people to actually make decisions. So using information for the best science and for the best decisions. And that's what I do now. I am the geology lead, as Rachel said, for this expedition coming up. Joining you from the ship, Casey's right behind me, actually. And I'm going to pass it back to Rachel.
Thanks, Deb. That's actually pretty cool, this sort of coming full circle with the Lost Vents site. How many people go to a place like that twice? We'll have to get you to write a little retrospective. Finally, we're going to hear from our biology lead, Joana Xavier from the Interdisciplinary Center of Marine and Environmental Research at the University of Porto. Hi, Joana.
Hi, Rachel. I thank you, and hi, everyone. Really nice to join you all, especially here in the Azores, nearly 25 years after actually I first made my trip to the Azores to study marine biology. So it's really nice to be back here now to join this cruise. So I did marine biology here at the University of the Azores, and this is really where I started exploring the oceans, doing diving, and actually started my interest on sponges and sponge taxonomy, and trying to understand, where species live and why do they live there and not in other places. So really trying to understand the diversity and distribution patterns of all of these species that inhabit our oceans. But I think my interest actually on deep sea exploration started back in 2008 when I did an expedition to the Goringe Seamount. So this is an incredible mountain that is located just 200 nautical miles off the southwest coast of Portugal, and that it rises from over 5,000 meters depth up to 28 meters from the sea surface. And so when we started diving there, I was just amazed and really started imagining what else would live beyond the summit of the seamount. And so this really took me then to do a postdoc already on deep sea sponge taxonomy and actually on diversity of these sponges, all the way to Norway, where I still hold actually a position at the University of Bergen. And then back to Portugal, where I now lead a research team at the Interdisciplinary Center for Marine Environmental Research at the University of Porto, and where we are continuing our studies on the biodiversity, biogeography, and conservation of these deep sea sponges and the habitats they form. So I'm really happy to join you all here on board the Oceanus Explorer. And back to you, Rachel.
Thanks. Yeah, so to kick off our discussion, I was wondering if you could each tell me a little bit about why were you interested in this particular expedition, this particular region? How does it relate to your research, or any other kind of stories you might have there? Oh, John, I can see that you're talking. Oh, there we go. Here we go.
Yeah.
Yeah, please.
Obviously for me, I mean, having studied here at the University of the Azores and having done quite a lot of work here from the early times, I actually went through a lot of monographs of explorations, past explorations, historical explorations done by Prince Albert of Monaco in the region. And of course, I was always there is an incredible diversity of sponges in the region. So over 300 species are known for this region, just sponge species. And 30 of those were originally described actually from material that was collected here. And so the Azores area and the seamounts and the Mid-Atlantic Ridge really constitute a hotspot of diversity for sponge on the North Atlantic. So obviously, when there was the opportunity to join an expedition to this area and visit some of these locations where we are quite confident that we're going to find a lot of sponge diversity, this was like a really exciting opportunity to join.
Awesome, and I imagine from the geology side, there's also. Oh, Scott, you were going to say something?
Sure. I'm not sure who goes next, but for me, there are two elements. One, very similar to what Deb said. When I was a student, I saw these hydrothermal vents. As I said, I wanted to explore them, and I did for my graduate work. But I was so focused on the hydrothermal vent communities that I didn't notice anything else around them. And it's funny because years later, as I was going through some images, I went, "Hey, there's a bamboo coral that I study now." And they were sort of on the way to the vent. So that's part of it. The other is my research has been focused on seamounts, deep seamounts, which are underwater isolated volcanoes. So here was an opportunity to look at a long continuous geological feature and say, or ask, how similar are the communities on those two environments? We actually have relatively little knowledge of the non-vent stuff that lives on Mid-Atlantic Ridge or mid-ocean ridges in general, because so much of the focus is on hydrothermal vents. So this is a natural interest to me.
Great, Casey?
So Scott, I think you actually hit a really interesting part about when we talked about this expedition years ago, why we started focusing on this area. So the Mid-Atlantic Ridge actually has had a lot of exploration in a lot of places, and a lot of it has led to incredible discoveries. Some of it you've already heard from Deb when she was talking about Lost City and some of the other vent sites along the ridge, and some of the work that Joanna has mentioned as well in this area. However, in a lot of these places, the exploration has focused on this tiny, tiny, tiny little pinpoint. So there are places on this ridge that have 20, 30, 40 remotely operated vehicle or submersible dives on it. Yet just beyond that, at a really cool looking seamount that is just feet away from it, there's nothing. No one has any information on that. So part of what we're going to be doing in a lot of these areas, particularly in the southern half of the Mid-Atlantic Ridge, which is the more studied half of the ridge, we will be looking at some of the areas just away from it. So there's a lot of interest in looking at some of these topographic highs, so areas that represent similar communities, like Scott was saying, to seamounts, but might be right next to a vent community that we've known a lot about for a long time, and looking at where those communities change and how they change and what they look like as you move further and further away from the vent. There's got to be more corals and sponges out there. There just has to be. We find them everywhere else in similar environments like this. So we're excited to look for them and see what we find. And then when we're looking towards the north half of the Mid-Atlantic Ridge and up into the Charlie Gibbs Fracture Zone areas, those were largely unexplored areas that we're still collecting that foundational data. So you saw some of the dive sites that we did earlier, and I'm thinking a little bit, you'll see a little bit more of some of the video from those dives, and we'll talk a little bit more about that soon, what we already saw this last leg, but we'll talk about that in a moment. Deb, do you want to answer about the question?
Sure. Although I think most of it has actually been said already. I mean, one of the things that I thought was most exciting about this was the opportunity to explore along the Azores and the Mid-Atlantic Ridge. And even though Casey said there's been a lot that's been explored, there's been so much more that hasn't. And I think that that's a really important thing to get across. There are lots of places where we think we've seen signals that might show that there are hydrothermal vents, but that doesn't mean that we know exactly where they are, nor have we discovered them. So it's a really exciting opportunity. And the other reason why I joined is the opportunity to learn from the other people who are on the ship, the opportunity to learn from our shore scientists, the opportunity to learn some of the biology, as well as seeing some fantastic geology is amazing.
Awesome. Thanks, everyone. Scott, it's funny that you mentioned, this experience of going back to past photographs and realizing there's this amazing bamboo coral that you didn't even notice, because my next question was going to be very closely related to that, to a conversation I had with you. I just wanted to share with some folks with some images and video of the biodiversity that's been seen on the expedition so far. And Scott, you had mentioned just this incredible dive, the sixth dive of the expedition we were just on, which took place on Kirchitov Ridge. You said it was your absolute favorite, and part of that was due to the corals. So tell us, what were you thinking when you saw this?
Yeah, so it's really interesting the way we have our process for these dives. If we go into areas that aren't previously mapped, that we don't really know what the bottom is like, then we have mapping that's going on overnight, and that was the case here. And we got these really nice maps of the axial valley of the Mid-Atlantic Ridge. So right in the center, right where our Earth is being born, the crust of the Earth is being born. And we saw this really neat ridge feature. And I said, we haven't had any dives between about 1,800 meters and 1,700 meters. And these are places where I would expect to see some very interesting sessile communities, these animals that attach to the bottom. And so we went there, but we didn't have, an expectation, really. We knew what possibly could be there, but we didn't know what we were going to find. And from the moment we touched down, for the hundreds of meters that dive track covered, was kind of like what you were just looking at. It was so mind-blowingly diverse. And you really need to think of these corals and sponges. An analogy would be the trees of a forest. And you have those trees, and you have all these other organisms that associate with them. And it's just so much color, so much movement. There's so much going on. And to me, this is the kind of thing where you just assume, well, the bottom of the seafloor, it's mud, it's bare rock, whatever. And we went down and we saw that totally different. It says there must be an awful lot of productivity in the overlying water. That sinking down allows all these organisms to grow, attracts fish and worms and various other things. Spectacular.
Amazing. And I know the others were watching from shore. Does that dive stand out? Or does anything else going on in your mind as you saw this?
So it's funny because when I got to watch a little bit of this dive, not the whole thing, but the biology is amazing. There are actually also beautiful pillow basalts that are hidden almost entirely by the biology. And then the other thing that you can see in that video is actually that there's tons and tons and tons of rubble from stony corals as they died. And so, you're looking at it and you're going, well, what's behind all of that biology? And it does give it a place for the biology to live. So we do want to also look at the very cool pillows that are behind it.
Yeah, I think that's well said, Devin. We had another dive where virtual pillows all the time, sometimes not with much biology. That was okay. Really cool geology. And I'll say the thing about the coral skeletons is it tells you that this community has been surviving there for thousands of years, multiple thousands of years. And so that was also a really good thing to see.
And was this site kind of unique in what you'd seen, or what do you think explains that? You mentioned a little bit about the productivity, and Jeb, you mentioned the actual physical structure that makes it.
It's hard to say because you get one shot, you get one dive, but I'll say two things. One is that depth range. So that was the only dive that we had in this depth range. So the particular species that we were seeing may have been different from others. The productivity, of course, is important. If you don't have the energy, you don't have the food, then you're not going to get this sort of luxuriant growth. But you noted that this was we called it Kirchitov Ridge, and that's because it was at a junction between the north-south running Mid-Atlantic Ridge and an east-west moving Kirchitov fracture zone. And we think that may have been impacting the way water flow is down there. And for these organisms that are creating the habitat, the sponges and the corals, they need their food delivered by water. So there probably was something to do with water flow.
Amazing. So moving on to the geology, we had a video kind of talking, well, a video I wanted to play, but this expedition, is named Voyage to the Ridge after the Mid-Atlantic Ridge. And I wanted to discuss a little bit more about why this place is so important that we actually named, an entire series of expeditions have devoted. We devoted these expeditions to the Mid-Atlantic Ridge. So we have a short video that gives some context. It's one of my favorites of the highlight videos that came out of this expedition. If we can go ahead and play that and then talk a little bit about the geology side of things.
Where we're diving now, we're approximately 150 kilometers west of Horta in the Azores Islands. For the last few weeks, we've been diving on the Mid-Atlantic Ridge. Right now, we're getting towards a really unique area, which is an area where three of these mid-ocean ridges intersect in what we call a ridge-ridge-ridge triple junction. And this separates the North American plate from the Eurasian plate, but also the African plate. We can estimate the age of the crust that we're on right now, this oceanic crust that's exposed in these normal faults, by looking at the spreading rate of the Mid-Atlantic Ridge, which is about 2 to 4 centimeters per year, and the distance from the ridge. And so we're on a crust that's maybe 1 to 2 million years old. Spreading on the Mid-Atlantic Ridge started about 200 million years ago, and we've had the opportunity to explore some of its youngest features, including these heavily exposed pillow basalts that you see in this normal fault. We've had the unique opportunity to explore the processes that shape our planet and impact the lives of those living in geologically active areas, including the people of the Azores.
Thanks. Can we pull everyone up on screen again? Awesome. Deb, you're the logical person to go to next as a geologist. But do you have, what are your thoughts there?
I mean, I think Ashton said it very well. That was his voice that you were hearing on the video. But the idea of, plates, tectonic plates that are generally fairly rigid structures that are moving away from one another. In this case, they're all moving away from one another. The globe is composed of these very big plates that are all moving away. Now, the Azores is actually really interesting because it is what we call a microplate, and it basically sits in the midst of all of these much, much bigger plates. And it's really cool because, again, what we always hear is plates are rigid. They move across the surface of the Earth through the lithosphere, the asthenosphere, and then down into the mantle. But this is actually an area where it's a little bit squishier. And so things are happening in a very different way. We call this a diffuse plate boundary because there are different things happening in the geology than what we would typically expect to find for the larger plates.
Awesome. And I think one of the most interesting things about that video and, kind of the work that we do in general in terms of data collection is just that these data really do impact people's lives. And we talked about geohazards and tectonically active areas. And I don't know if anyone wants to speak to that, like what the information we gather here can do for people who don't live in the deep sea, but, live in these adjoining communities that might not, you don't really think about the deep sea as affecting you on your daily lives, but certainly can.
Yeah, Deb, about the geohazards, go for it.
I can talk about that too. That is one of the main things that we're really looking for here is trying to understand how the geology can impact the world and society, and that's through the geohazards. And so when we're talking about plates and how they move and change, we have things like earthquakes that happen as the plates are pulling apart. We have things like eruptions that are happening when the plates are pulling apart. And all of those have the ability to impact people if they're close enough. And so in the Azores, this is actually a fact of life. One of the last eruptions on the island that we're sitting at right now was in 1957. So they, have recently dealt with eruptions, and they have often dealt with earthquakes. Other things that we are also thinking about could be things like submarine landslides. So landslides beneath the water that cause other problems for people. So we are really interested and concerned about making sure that we understand the geology because it has such a direct relevance for society.
I can say from the biological standpoint, I talked about productivity earlier, and what I meant was that most primary production, sunlight, plants, phytoplankton, takes place in the upper surface of the water, and much of it then sinks through the water column to the deep sea. So there's a direct connection between what's going on in the surface of the water and these organisms, these communities that you see in the deep sea. But there's something called the biological pump, where organisms will, in the surface water, feed. They can swim down into the deep, but they can also migrate back up. And we haven't talked about the goals of the program with respect to midwater exploration. That's something else that we do. And if you've tuned into any of those dives, you heard us talk about the deep scattering layer. And that's this layer in the water column where there's a concentration of fish and shrimp and mysids and so on. And they actually move up towards the surface and they come back down. And again, a direct link of the deep sea to shallow water and vice versa. The other thing about productivity sinking, it means that the dead carcasses, the fecal pellets of all this stuff at the surface of the water is sinking. It's all has carbon in it, right? Plants are taking carbon dioxide out of the atmosphere and incorporating into their tissue. And so we talk about the deep sea as sequestering carbon because of this biological pump. All the organisms take the carbon out of the water, it's drawing it out of the atmosphere, and then it sinks into the deep sea. Some fraction of that gets buried. That's hugely important because that largely controls the climate that all of us experience, not just the Azores, but worldwide.
Thank you. One of the other things I want to talk about was collaboration and partnerships. Joanna, I think you're with, okay, good. You were frozen earlier. I just wanted to make sure you're back with us. But yeah, so we talk about partnerships a lot, and we have scientists from kind of all over the world who are able to participate in the dives from their home universities, from their homes, and also contribute information and annotations. We also have an expedition command center set up at the University of Azores. And Joanna, I was hoping you could tell us a little bit more about some of the partnerships and some of the collaborations that have been going on.
Sure. So I think one of the greatest things about these Oceanus Explorer campaigns is that all of this exploration is actually co-designed. So there is this entire community at large that comes together to define priority areas for exploration. And then we visit some of these locations, taking into account, the entire community objectives. So they may be, biological, they may be geological, they may be archaeological. And so it is really nice to see how exploration can be conducted in such a co-designed way. And so in the specific case of the Azores, this has been really, really relevant because they've been doing a lot of research in the area for many years now, using other types of technology. And so what the Oceanus Explorer campaigns is bringing to this is that they're able to actually cover a much vaster area and really understand not only on the Azores Plateau, but all along the Mid-Atlantic Ridge, both to the north and to the south, some of these biodiversity and biogeographic patterns. So I think the really cool thing about these expeditions is the way that science is co-designed and ends up being co-delivered, and how all of these data and all of these samples will ultimately be available for the community at large, be it national or international.
Thanks. And Casey, as the expedition coordinator for this part of the expedition, or this upcoming expedition, you've done a lot of work in this area. Would you like to speak to that?
So I think one of the best things about the way that we conduct our operations is through this open and collaborative process that Joanna is talking about. So it's not just in tune in and join the dive, but it really is from the get-go. We solicit people's we use a call for input. We solicit people's input way in advance of expeditions. How to what are the priorities throughout the entire basin and the regional areas that we're working in, and then sort of continue to use their input to distill down, get the content a little bit more specific each time we go through that process. But a lot of what we can do with here on the ship and the work that we're able to do, it's really only possible with participation of people from shore. So we use telepresence technology. So the same kind of technology we're using right now. Actually, this is being hosted by the Inner Space Center at the University of Rhode Island. And this isn't all that different from the work that we do all the time with all of our dives. We send video to them, they route it out to the public, and it's all part of that process. It's a great partnership, but it allows us to connect with people anywhere in the world with just an internet connection. So you can be doing deep sea science anywhere. You don't just have to be based on a ship. So that gives us an opportunity to engage a larger science capacity than it could have if we were in just one research vessel. And it allows us to be more interdisciplinary and explore more things than we would if you just had a geology cruise, or you just had an expedition that was focused on corals, or maybe even an archaeology mission. By being able to leverage the intellectual capital that's on shore from anyone, anywhere, we can support more than any one single research vessel could support on a ship. We have limited berthing at sea, so anything that we're able to do to kind of offload some of that science capability to shore makes it so that we can do more on the ship, and we can do a lot more with everyone on shore. It's a really cool technology that honestly, it's changed so much even in the last 10 years or so since I've been working with Noaa Ocean Exploration, and it's really incredible to see how far we have come with this technology. Just earlier this year, we used the same technology we used to typically engage science leads and our science team on shore. We used it to, with our partners at the Global Foundation for Ocean Exploration, to remotely control the ROV from shore. So the ship was working in the Gulf of Mexico, and they were able to pilot it from shore from Newport, Rhode Island, which is just shows you how cool this tech is and how far we've come. Scott, you've been engaged with us for forever as well. So do you want to add something?
Yeah, I've been very lucky. Thank you for continuing to engage me and not get tired of me. One of the things that I love to tell people is when I was a grad student, I talked about this at the beginning, I had this amazing opportunity to get into the Alvin submersible and go down and see a hydrothermal vent. Now, when you're in the Alvin submersible, there's a pilot and 2 scientists, and that's it. So all the observations that you're making, all the decisions you're making on what you're seeing, it's those 3 people. And then later in my career, I transitioned to using an ROV, a remotely operated vehicle. That's operated from the deck of a ship. So now you have everybody who's in the control room And then we started to add monitors in different parts of the ship. So now it's everybody on the ship can be involved in what do you see and what are the decisions to be made. And now with telepresence, all of my colleagues all around the world are involved. And it's amazing. Deb and Joanna, you'll see this when you are doing these dives. It's so valuable to have this chat room where you have all these scientists, they're chatting with each other, they're making points to you, they're providing you information if you see you don't know things. And there's a really neat confluence there. If everybody's saying, I haven't seen this before, bang, we have just seen something that, oh, this would be great to sample, get better video, whatever. It's a beautiful system.
That's great. And Joanna,
Sure, and I think, yes, so adding on to that, I mean, just the potential that this has to really engage the public in general. You know, I remember, you know, you can do this, you can follow these dives, you can be sitting on your metro. I've been doing commuting quite a bit, and I remember, you know, following some of these exploration and some of these dives just sitting on the metro and actually getting people very interested to what is it that you're watching, and you just show them, and you know, it's incredible. I've got, you know, my entire family also engaged in following these ROV dives, and it's quite spectacular to think that you can be sitting, you know, so many thousands of miles away and just be sitting on your living room and just following a dive that is taking place 4,000 meters depth, you know, surveying a seamount or surveying an isothermal vent, you know, with just a 2 or 3 second latency. So this is as close to being an explorer as it can get, really, if you are not a scientist. So I think just the potential of this technology to really get people the perception of what it is like to explore the deep ocean, and the relevance of this exploration is just phenomenal.
And if I might add, I was watching it on the metro in Washington, D.C., while Joanna was watching it on the metro in Porto, Portugal. She was probably coming from work while I was going to work. And I think that, you know, it sort of adds to that excitement that you can really be at least enjoying the science, even if not perhaps directly helping it, from anywhere. And, you know, the other thing that's cool about it is I was watching one of our dives and contributing, and we all came across a question that nobody knew the answer to. And I was able to text a friend who's a geochemist and say, can you turn this on really quick? Can you look at this? Can you tell me what we're seeing? And I thought that was really fantastic too. It's that idea that you can keep pulling people in as needed to get the questions answered, or at least to say, wow, none of us know what this is. Maybe we should sample it, as Scott was saying. And I think that that's a really fantastic part of the you know, why we do what we do, because it brings so many people in that wouldn't otherwise have the opportunity to join us.
That's great. Actually, I'm curious, Deb and Joanna, you know, having participated from shore, and now going out onto ship and being sort of responsible for the science community and for, you know, everyone has, you know, their own perspectives and priorities. How has that experience being on shore kind of informed how you're going to go forward, and what are you looking forward to there, being science leads on ship now?
I guess maybe I'll start, and then Joanna can jump in. You know, the problem, I'm going to be perfectly honest, it's actually really hard to do from on shore sometimes, because I was trying to finish up my day job and get all of the pieces settled so that I could leave for over a month to come join the ship. And so I wasn't able to join it as much as I had wanted to, because I would have liked to have been there every single day for the entire time. But I could drop in and see what was going on and check to make sure something was cool, and maybe throw in a contributing to what Ashton and Scott were talking about as I could. And I think that that's the really great point where you can contribute from shore. And I think it will help with me and Joanna when we're here helping to make sure that we read the chat, make sure that we understand what the scientists on shore want from us, because we're not really, we're speaking for the whole community. It's not about what just the two of us want, as Scott was saying. It's about what the community needs. And so we're there to help translate that information from the people that are providing it, and making sure that we can get the best science that we can out of each dive.
Yes, and I mean, if I may add to that, I totally agree. I think the greatest thing of being now on board is actually that we can focus 100%, 200% to actually the dive, because when we're on shore, there is always this balance you have to do with your other million tasks. And I think it gave me a really good perspective on, how we all of the community need to come to compromises when it comes, to select the right sample to be collected, to select the right rock, to select the right measurement of, of conditions. And I think, I think this is just the entire experience, having been there for a number of cruises now in the past few years, and now being on board, it's just an amazing experience, really.
Awesome, thanks. So there's one highlight that I have to address in this this webinar, because it's really taken off, which it's always surprising to see kind of what are the most exciting things. And for us, definitely the media's most like the favorite part of this expedition has been these very mysterious holes found on the bottom of the seafloor. We do have a story about this on our website, and there's a link to a scientific paper on the subject, but would love to kind of just hear your thoughts about both seeing this as well as the reaction that it's had in the public and in media. It really has taken off. I don't know if we can play that clip, but I don't know if someone wants to start. Scott, you were there. What are your thoughts on the holes?
Yeah, so it's interesting because we had actually received a message from Mike Vecchione, who is one of the co-authors with Axel Bergstad on the paper that was written back in, I think, 2018 about observations made in 2004. And he said that not far from here, they had seen these features, these very regular linear features, they're just too regular to ignore. And he said, maybe you'll see something. And towards the end of this dive, we did in fact find them. We were all so surprised that we found them, and very similar in pattern to what he had described from his paper from dives in 2004. And then on a subsequent dive, I think 2 subsequent dives, we found some again. Some of them are quite abundant, as you're seeing this video here. And so there was a lot of curiosity, if they didn't know what it was and they had done a pretty thorough research and we didn't know, what could they be? And so this hit the internet, and there were all kinds of suggestions of what they might be. And using the tools we had available to us, we explored it a little bit more. We did a lot of close-ups into the holes, hoping that we would see something coming out. One of the main hypotheses is that there's an organism that's building a tunnel below the sediment surface and excavating out of that tunnel periodically in order to allow better water flow. And this does look like they're holes that have been dug out from below. So that's a good possibility. So we were looking at one end to see, could we see anything? We actually suctioned into the hole. Unfortunately, we didn't recover anything, some sediment, but we didn't require any organisms. There are things that look like this in the fossil record, so that's interesting. But the bottom line, here we are suctioning. We also took some eDNA samples, some water samples to process for eDNA later on. But the bottom line is everybody loves a mystery. That was revealed, and I think that's, the beauty of this exploration that the Okeanos Explorer does, is everybody can be involved in seeing that mystery and coming up with their own ideas. So it was really exciting. Glad everybody enjoyed it so much. We still don't know what they are.
Thanks so much. So we're running short on time. I do want to leave at least 10 minutes for the Q&A. If really quick, I figure we can kind of combine some of the other questions that we had. So if you could tell us, kind of everyone, maybe starting with you, Deb, and we'll just go around in a circle. What was your favorite moment or most surprising moment, or what are you most excited about? And Joanna, you had a really lovely story about your children that sort of fits into this, but not quite. But I think that would be a lovely point to talk on, if we can just really kind of do a quick wrap up with everyone. So it's starting with Deb, and then we'll go to Casey, Scott, and then.
Okay, so quick wrap up. My favorite part of the previous part of the expedition that Scott and Ashton were the geology and biology leads on was the Moitira event field, which was an amazing, amazing dive. We spent most of our time looking at extinct sulfides, which are extinct chimneys on the seafloor. And we saw some really cool geology that, like, some of us had never seen before. We saw things that looked like malachite, which is a copper oxide. And we were like, is that really that? and we saw chalcopyrite, which looks like gold but isn't. And then after looking at all these extinct things, we get to the end of the dive. We only have just a very short period of time left. And this is what we see. We see a huge vent that's active and is just a really interesting morphology. The shape of the vent was very cool. And you could see the shimmering water of the active vent. So that was just amazing. And I hope we see a lot more like that on this next leg of the expedition.
Awesome. Up next, I think we had Casey.
So my favorite thing about the expedition so far actually probably came from the first expedition. So early, I'd say about a month ago, early May and into June, we conducted an mapping expedition up into the Charlie Gibbs Fracture Zone. So this is an area that when we first started working in the Atlantic Basin, again, it was a huge request from the community in order to get up into the Charlie Gibbs Fracture Zone and collect new data there. So we spent a whole expedition there mapping that area, and the data that we got was absolutely incredible. So it looked sort of like just based on the satellite data, which is based on gravity anomalies. You can see here in the top cover of the image, just the how the seafloor kind of looks kind of soft and just sort of a little droopy. I'm sure there are more scientific terms to describe that than I just used, but you don't have much detail here. So if you look at the bottom image, though, you can really see the type of data that we're able to collect using our multi-beam imagery and how this has the ability to really give us an idea of what types of features are there. So this is a section of the Charlie Gibbs Fracture Zone that we didn't have good data from before. And now after this expedition, we have really nice data that has joined up with some of the data sets from our European colleagues. And it's really nice to provide that data in support of some of the sort of global initiatives that are going on right now to map the unknown areas of the seafloor, like Seabed 2030. So that was what I was most excited about, watching that data come in. We have a live operations map, which you can find online. You can watch basically every day. The new data will pop up. It is my favorite part. You can go in and like zoom in and start kind of playing around like, ooh, I want to dive here. Ooh, look at this one. Look at this one. I want to dive here. It is way too distracting, but I absolutely love it.
That's great. Thanks. Who is next, Scott?
Maybe I am. Okay, maybe. So I'd say that my favorite moment. Yes, I'd say that my favorite moment was actually. Sorry. Am I unmuted now? Yes. Okay. So my favorite moment, and maybe I'm a little biased here, was actually to see the glass sponges that were hosting the little shrimp inside. So we've been collecting those sponges for a number of years, and we know that they are associated. They have there's a very tight association between these couple of shrimps that live inside of the sponge. So it is thought that they come into the sponge, was larvae, as a very small larvae, and then they start inhabiting the sponge, and the sponge just builds this super intricate skeleton of biosilica. And at some point, actually, the shrimp just becomes too large to actually be able to exit the sponge. And I think the fact that we can now see this association so clearly is really, really interesting. And it only shows, how in the deep sea, all of these associations have come into play under such potentially difficult conditions. And it's great to see, how that little shrimp has just found a fantastic glass condo to live in. So this is actually my favorite part of the previous expedition, and I hope we'll come across a few more of these.
That's awesome. Thanks.
So my favorite part, usually when I get this kind of a question, people think it's going to be something really big, a shark or a huge coral or Volkswagen size sponge. But in fact, for me, it's the really small stuff. And that's because it speaks to the power of the cameras that are on the D2 ROV and the video engineers that we have. So we can see sub-centimeter organisms. And this is just a gold mine for anybody who's interested in the ecology of the deep sea. This is stuff that we don't get to see. I don't know how these things are fulfilling their daily life. So I can think of 3 examples in this cruise: some Nemerdian ribbon worms that were coiled around a coral, some aplacophorine mollusks. They're specialized predators of worms. And Deb was referring to the Moitira vents, and we were looking at these extinct inactive sulfides. And when we zoomed in on those rocks, they were covered with these skeleton shrimp, these capellid amphipods. They're less than 1 millimeter in diameter and maybe less than 2 centimeters long. And yet we were able to see them. We were able to see what they were doing, interacting with each other. I mean, it's mind-blowing. We're basically going into the deep sea with a dissecting microscope. What could be better for an invertebrate zoologist? So that's what I always love.
That's great. Thanks. So we've had a few questions come in about sort of different career paths and whether it's possible to get into the field if someone isn't studying geology or biology. Wanted to know if someone wanted to discuss about career paths, but also I think something, that's come up is sort of managing different identities and managing, say your day job before you go out to sea for a month. And what your experience there has been. Johnny, you had a really great example about how you stayed in touch with your family and how you manage, being a parent at sea and with this really exciting job. So maybe we could start with you and then go on to Deb. Deb, it sounded like you had something to say as well.
Sure. So I find, that managing, and really finding a good balance between your work and your life it's not always super easy. And of course, for a mom to go away on multiple cruises a year for a long period of time can be actually quite challenging. But I think, with this, there's now just so many opportunities to actually have people and have your family engaged. So in my specific case, for instance, I always show the vessel that I'm going to be in. I show them the track, the plan of the expedition, and tell my kids a little bit about the expedition before I join. I actually carry 2 of their plush toys that are my little helpers. They're actually Drop and Monkey, and I take pictures with them around the ship and send those pictures back home. And we both keep a diary. So in my case, I keep a diary here on board, and they keep a home diary. And so when I'm back, we have a special moment together where we share our experience and we share our findings throughout that time that we've been away from each other. And I think this really is a good example that we can be multiple things in our lives, and that we don't have to do the things that we're really passionate about just because we have also another social role that in our lives. And I think this really sets a good example for my kids. That their mom is also an explorer, and that they can join me to some extent in those explorations.
That's great. Thank you.
Joanna, that's just a great example. Like it's so wonderful to hear about. I'll take it from a slightly different direction. From my perspective, it's not just about geology or biology. If we're talking about just the sciences, chemistry is incredibly important. And so people who study chemistry, could certainly very quickly transition into the world of oceanography. People who study physics are really important because we need to understand how water moves and how the ocean changes over time. So from the academic perspective, there's a whole lot of sciences that we need in order to understand the deep sea world around us. But there's also a ship of which we are just a very few people on it. And so there are so many people that are making ocean exploration work. And we have people who do video tech in terms of, they make sure that our video is amazing and they put it all together and they package it beautifully, and they are incredibly gifted at what they do. We have lots of engineers who make the ROV, the remotely operated vehicle, go well. So that's really important. We have people who do nothing but make sure that the computer databases work, because if we're not taking that information and making it usable for everyone, it's not really worth going out. We have crew who do everything from making sure the ship is maintained, making sure it's going in the right direction and it's staying where it needs to stay. We have stewards on board who are basically cooking for the whole ship. We have people who are maintaining the engine room. So there are lots of places where you can be a part of ocean exploration, even if you choose not to be a geologist or a biologist. And there are other, on some other expeditions, you can bring out also social scientists who might want to talk about the impact and influence of humanity, as well as as the sciences that we've talked about previously. And then finally, I would throw out that we've actually, on some of the previous expeditions I've been on, not with Noaa, we've brought out artists because there's such a connection between science and art. And so there are so many places that you can be attached to ocean exploration. And I will pass it on to somebody else because I'm sure that somebody else has a great answer too.
You took the words right out of my mouth, Deb. So there are so many different ways to get engaged. I would say that it starts right from if you're a school kid or you're a teacher that teaches children. We have lots of free lesson plans on our website, and they are basically ways that you can incorporate deep ocean exploration into your daily life in the classroom. And they're standards-based lesson plans that allow you to basically provide a connection to the deep sea. And now you have our website up, oceanexplorer.noaa.gov, but it's a way to provide a connection to the deep sea for people that maybe don't always see it. And that's, I'd say 99.9% of the people on this planet never get a chance to see the deep sea unless it's through something like this. So in my mind, some of the things that we can do best to sort of help grow up that next generation of ocean explorers is provide access to the deep sea for them at a young age and start building those connections early. And whether that's you follow us on our social media channels, or whether that's you watch the live video streams, or you learn about like how sound travels through the ocean through one of our really cool and really interesting like hands-on engagement activities with the kids through our lessons plans, or whether it's that you follow along and just kind of participate with us as a scientist. Once you're engaged, you hopefully stay engaged in this world for a long, long time. And as everyone has already mentioned, there are so many different ways to stay engaged and so many different opportunities to make this a part of your world that we hope that you'll join us.
Thanks. And so we'll wrap up with one last question. Someone asked this online. How often do you make a new substantial discovery, be it a new species, behavior, feature, or something you can go to bed thinking this was a productive day? And I would just say generally, what at life at sea, being a scientist, what is it that makes you say this was a productive day, we did a good job, and you feel satisfied? Scott, did you have an answer to that?
Sure. I'm going to say every dive that we have an opportunity to see part of our seafloor that we've never seen before is already a discovery. And maybe there's going to be a new species. We won't know that for sure till we get it back to the museums and do a lot of extra work. But every single dive, you're going to see something that is novel.
That's great. Anyone else? Casey?
Yeah. So I'll actually just add to that, just with a very, very recent discovery that just came out. So certainly I completely agree with Scott that every day we're seeing something new. My favorite time is actually when everyone's quiet on the line, when everyone's kind of looking at things like, what is that? And like they've all muted themselves and they're all kind of like, oh no, I don't know, I'm not sure. That's my favorite time every day. And if we get one of those moments, which usually happens about once a day, every couple days or so, that's my favorite time. And I find that to be very, very successful when we can stump people, because that means we're collecting very valuable data that it's on things that no one's seen. But Scott was mentioning before about like potential new species. So one of our colleagues who works at the Smithsonian just recently actually described a series of new sea stars that were from our expeditions. And one of them was actually named after the Okeanos Explorer. One was named after the work that we did, that Noaa Ocean Exploration did in the Pacific, our capstone campaign, which is actually the map that's directly behind Joanna's head in the control room. And another one was named after our partners GFOE. And another one was named after one of our expeditions to the Musician Seamounts. So it is really cool to see all of these new species be discovered and to have that ability for them to get described. It's part of the reason we collect samples. It's part of the reason that we work so closely with the community to collect certain things that are going to be very valuable and have the potential future for discoveries and future applications.
That's great, Casey. Thank you so much for wrapping that up for us. We're right about at the half hour. So we'll close here, but thank you so much for being with us, both to our scientists and to our listeners. The ship will leave port on Saturday to begin the third and final Voyage to the Ridge 2020 expedition. The remotely operated vehicle dives will begin on Sunday and continue through August 28th. So you can definitely look at the live streams, hear more from Deb and Joanna as they narrate these dives and tell you all they can tell at oceanexplorer.noaa.gov. That link is in the description below, as well as our social media platforms. So you can follow along there, and you can also keep asking questions. They will respond to you, or we will respond to you actually on their behalf once we get the scientific answers. So again, please join us online, and thank you again for being here. Bye, y'all.
Thank you all.
Bye.
Ciao. Bye.
Enjoy the next leg.